In this video, we're going to talk about solving inequalities involving absolute value. So let's go ahead and get started with this example I have here. So the absolute value of x is less than 1. Okay, so what is the absolute value of x? The absolute value of x is the distance that you travel from the that you travel from 0. So the absolute value of x is the distance that you travel from 0, right? That's what absolute value is. So we're going to travel from 0, and at most, when we're traveling from 0, at most we can go to -1, right? Because the absolute value of x must be less than 1. So this distance at most can be 1 from 0. And then in the same thing in the other direction, it can at most be 1, right? And then I could be less than that, right? The distance that I travel could be less. It can be less than 1, but at most it must be 1. Okay? So there you go. That's my solution. So x can be any number between -1 and 1, including -1 and 1, because it can equal, it's less than or equal to. So if I were to draw my solution, I would have, let me go ahead and do it in red, I would have dots on -1 and 1, and then I would include any number between. Okay, so that's my solution. I would write this in interval notation as -1 to 1, and then use brackets. All right, moving on to a slightly more difficult example, but same idea holds. So here is 0, here is -10, and here is 10. Okay, now this absolute value, this side must be less than 10, right? So that means we're traveling a distance of 10. So we're traveling all the way to -10 or traveling all the way to 10, right? So that means that 7x minus 4 must be between 10, okay, or -10. So 7x plus 4 is greater than -10, and it's less than +10. Alright, so now I can just solve this for x. I'm going to add 4 to both sides. Or I'll add 4 to all sides. -10 plus 4 is -6. 10 plus 4 is 14. Divide everything by 7 to get x by itself. So -6 over 7 is greater than or equal to x, is greater than or equal to 2. Alright, so you would write your answer in an interval notation as -6 over 7, comma 2. Alright, moving on to another example. So in this one, again, we have that the distance is less than some number, right? So the distance that we go from 0, this is the distance that we go from 0, it must be less than -5. Well, wait a second, right? Because absolute value of any number is going to be a positive number, right? Absolute value is a distance, and distances are positive. So this is going to be some number that is 0 or more. Well, 0 is never less than 5. Or -5. 0 is never less than -5. So there's no solution to this. There's no x that will satisfy this inequality. No solution. Alright, moving on to another example. So in this one, it's different in that we are greater than now. Okay, so we have to think about this a little differently. So the distance that we travel from x must be greater than 15, right? So if here's -15, and if here's +15, I must travel further than that, okay? So my solution must be greater than -15, or sorry, not greater, less than -15, right? Because we're going in the negative direction. So I must be less than -15 or more than 15, right? So 5x must be less than -15, or 5x must be greater than 15, okay? Because this distance that we're traveling from 0 must be more than 15. more than negative 15 in this case. Or, well, the distance must be more, which means that 5x must be less than negative 15, okay? The distance must be more than 15, which means that 5x must be more than 15. Alright, so let's go ahead and solve for x. Divide both sides by 5. X is less than negative 3. Divide by 5 here. X is greater than 3. So if I were to draw this out, here's 0. Here's negative 3. Okay, so x is less than 3. Looks like this. X is more than 3. Or x is less than negative 3. I think I said negative 3. X is more than 3. So that looks like this. Okay, and then we have an open circle because we don't have the equal sign, right? Alright, so we go from negative 3 to 3. Okay, so this is another example where it is greater than. So we have greater than. But when we're looking at this one, first off, so we have something that says the absolute value is greater than negative 3. Okay, so let's think about this for a second. Because absolute value is always more than 0, right? The distance that you travel is always 0 or it's more. So no matter what I put in for x, I'm gonna be meeting the criteria of this inequality, right? So no matter what I put in here, I'm meeting the criteria. So that means that this is always true, right? The absolute value is the absolute value of anything. The absolute value of anything, like, I don't know, I'm just having another variable there, but the absolute value of anything is always greater than or equal to 0. So surely it's greater than negative 3 then, okay? Excuse me. So solution is negative infinity to infinity. Alright, last example. So this one is a little trickier in that, we don't first, we have two inequalities here. So, and we need to always start, sorry, not two inequalities, but two absolute values here. And we need to always start our, solving inequalities with absolute values. We need to always start by getting the absolute value by itself. Okay, so the way I'm going to do that is I'm going to divide both sides by the absolute value of 3x plus 2. Okay, so that will make this equal to 1. If I do it to one side, I must do it to the other. So I'm going to have here 2x minus 1 divided by the absolute value of 3x plus 2 is less than or equal to 1. Now, if this top half is positive, then, and the bottom part is positive, then the whole thing would be positive, right? Well, actually, no matter what, the whole thing is positive, right? So, like, even if the bottom half is negative, and then we have a positive time divided by a negative, the whole thing will be negative, but then the absolute values take care of the negative, right? So it really doesn't matter that I have the absolute value of, what's on the top and the absolute value of what's on the bottom, or if I just had the absolute value of the whole fraction, okay? So I can just rewrite this as the absolute value of, the fraction. Okay, so now once I have that, then I'm going to draw my number line again. I'm going to try to understand this. So I have, 0 here, and I need to travel a distance that is less than or equal to 1. So I'm traveling a distance that's less than or equal to 1. So I get to negative 1, I get to 1. Alright, so that means that this 2x minus 1 and 3x plus 2, it must be between 1 and negative 1. Right, because the distance I travel from 0 is less than or equal to 1. So I'm traveling along, I'm allowed to stop there. I'm traveling along, I'm allowed to stop here. I can get all the way to 1, but I must be less than 1. Okay, same thing on the other side. Okay, so now that I'm here, this is very similar. Previously, we solved inequalities involving involving, fractions. And this is a very similar, sort of situation. Okay, I can I'm going to actually break this down into two different pieces, though, just to make it a little easier. It doesn't matter. You could do it together as one piece, but I'm going to do it in two different pieces to make it a little easier. So first, I'm going to look at this piece here. So I have 2x minus 1 divided by 3x plus 2 is less than or equal to 1. Okay. The second piece I'm going to look at is this one here, which says that 2x minus 1 divided by 3x plus 2 is greater than. You see how it's, the alligator is based towards, the fraction? So it's greater than or equal to 1. Negative 1, actually. Negative 1. Okay, so now I'm just going to solve this as if I was, solving any other inequality involving, fractions like this. First thing I need to do is get 0 on one side. So I'm going to subtract 1 from both sides. So I'm going to have 2x minus 1 divided by 3x plus 2. I'm going to subtract 1 from both sides, so I'll have minus 1 less than or equal to 0. Okay, actually, I'm going to move this to the next page because I'm running out of room here. Okay, picking up where I left off on a new page. So I have minus 1 here, and first, so now I need to get these guys together. I need to get common denominator on the bottom. So I have 2x minus 1 divided by 3x plus 2 minus 3x plus 2, divided by 3x plus 2. Notice that, this is 1, right? And so it's negative. So this is these are the same thing. Okay? But these two have the same bottom, so now I can combine them. So I have 3x minus 1 minus 3x minus 2. Don't forget that this minus sign gets distributed into each piece that's on the top. Alright, divided by 3x plus 2. Let's combine. Oh, let me not forget the other side of the inequality. Alright, now let's combine like terms. So I have 2x and 3x. It's 2x minus 3x, which is negative 1x. Negative 1 minus 2 is negative 3. Okay? Oops. So now, you remember how to do this using test points, right? Where we say, okay, so it's going to equal 0 when the top equals 0. So in other words, so I'm going to add 3 to both sides, and x equals negative 3. So when x equals negative 3, so here's 0, 1, 2, 3, negative 3. That's a solution because, equal 0 is a solution. And then also we have to be concerned about the bottom and when that equals 0 because then it'll be undefined at that point. So let's subtract 2 from both sides. We'll get 3x equals negative 2. X equals negative 2 over 3. Okay, so negative 2 over 3. So that would be right about, so negative 2 over 3 would be right about there. Okay, so, here's negative 1, here's negative 2. 1, 2, 3. Alright, and then right there at negative 2 over 3 would be an open dot because that's where it's undefined. So that little circle there, that's an open circle. Okay, and so now I just need some test points. I need to figure out when this fraction is negative and when it is positive. So, so I'm going to go ahead and first I'm going to start over to the left. I'm going to use a test point of negative 4. So that'll be negative 4, and then it's also negative because it's negative here, minus 3 over 3 times negative 4 plus 2. So these two negatives cancel, so that's positive 4. Positive 4 minus 3 is 1. And then this will be negative 12 plus 2. So it's a positive divided by, so negative 12 plus 2 is negative 10, right? So that's going to be positive divided by a negative, which is going to be a negative. So it's going to be negative over there. Alright, let's plug in another number between negative 3 and negative 2/3, so such as negative 2. So I'm going to plug in negative 2, and so I'll have 3, negative 2 plus 2, and then so the negatives will cancel here, so it'll be negative. So it'll be 2 minus 3, which is negative 1, and then this will be negative 6 plus 2. So that'll be a negative number up top. On the bottom will be negative 4. Negative and a negative make a positive, so it's going to be positive between the two, those 2 points. All right, let's try one more test point. Let's just go ahead and plug in 0. So we'll do 0 minus 3 divided by 0, 3 times 0, which is 0, plus 2. Okay, so that's going to be negative 3 over 2. That's a negative number, so it's going to be negative over there. All right, so the goal, I'm going to go ahead and erase all of this. The goal was to know when is the fraction equal to or less than 0, right? So we're going to be less than 0 when we are less than negative 3, right? When we are in this area, and then also when we are more than negative 2 over 3, right? So let's go ahead and write that down. So less than negative 3, and then we'll go all, so, oops, sorry, that's not right. So less than negative 3 would be negative infinity all the way to the point that we get to negative 3. Now actually, do we include negative 3? Yes, because it's a solid dot. Why is it a solid dot? Because we're allowed to equal 0. Okay? And then also, when we are more than 2 over 3, negative 2 over 3, all the way to infinity. Now do we include negative 2 over 3? No, because that's when the bottom of the fraction is equal to 0. So that's undefined, so it's not included. Okay? So that's part of it. Now we have to think about the other side. That could be true. So remember, let me draw a line here. All right. So we need to go through the exact same process and do that here with this other side. I'm going to pause the video and do these steps. I'm going to write them out here, and then you can go through them and look at them, and then I'm going to rejoin you once I've done those steps, and we'll talk about it. Okay, so now I'm rejoining you. You could also pause the video and make sure you get the same answers as me. But okay, so what's going on here? So I went ahead and I did the exact same steps that were done over here. So I added 1 to both sides, right? Because this was a negative 1 versus over here it was a positive 1. So now I added 1 to both sides, so I get 0, and then I combined into one fraction, and I simplified, and I set the top equal to 0, and I set the bottom equal to 0. And where the top equals 0, that's a solution, okay? And so that's marked here as in the dot, because when the top equals 0, it equals 0, and that's a solution. And then when the bottom equals 0, that's when it's undefined. So that's why you have an open circle there. Then I went ahead and did test points, and I found that this fraction is positive to the left of negative 2 over 3. It's negative between negative 2 over 3 and negative 1 over 5. And then it's positive again when it's greater than negative 1 over 5. Okay? And then, this one was asking us to, we wanted to find when it was positive, right? Because we want it to be greater than or equal to 0. So then our solution then would be, okay, so it's greater than or equal to 0 from negative infinity to negative 2 over 3, and then that in combination with, hard bracket because we are going to include it, the negative 1 over 5 all the way to infinity. Okay, so now let's look at this. So we have two different things going on. What's going on here? Now, this inequality and this inequality must be both met, right? If you go back to the previous page when we were talking about this, this fraction was between negative 1 and 1, right? So this fraction must be between both those numbers. So both these inequalities must be met. Okay? So if I'm looking at this and I'm saying, okay, so x is less than negative 3. All right? And it's more than negative 2 over 3. And then also x is, on this side over here, we say x is less than negative 2 over 3, and then x is more than 1 over 5. Okay? So we have to find where both of these things are true. It's not going to be true for all of them, right? So we are, let's see, let's look at this. On this side, so from negative infinity, okay, we're going good, we're good. Both of them are being met from negative infinity. And then we get to negative 3. Are both of them met? Yeah, both of them are still being met. We're at negative 3. Both these guys are met. Then we get to, let's see, we continue moving past negative 3. And we're trying to reach this negative 2 over 3. Are both being met? No, right? Because while the one on the right over here, you know, yeah, like we can go all the way to negative 2 over 3. But here we have to stop at negative 3, right? So only from negative infinity, so I'm going to write my solution up here, negative infinity to negative 3. And then we can include negative 3, so that's a hard bracket. Okay, and then we have to stop there at negative 3, though, in order to meet both inequalities. Okay, so now I'm going to do the same thing going from the positive infinity side. So I'm gonna go traveling on the positive infinity, right? And I'm good. I'm meeting both, both of these lines, right? I'm going, and then I get to negative, so I get to 0, right? I'm still good all the way up to 0. And then I get to negative 1 over 5. And I'm still good for both of these, right? Because this one goes all the way to negative 2 over 3. Negative 2 over 3 is less than negative 1 over 5. So I'm still good. But then once I try going beyond that, this one will still be met, right? But this one won't. So I'll have to stop there. So I'm going to have to stop at negative 1 over 5, but then I can go all the way to infinity. Okay? So there you go. This will be my solution here.